Hi everyone, new track, this time with Grace Jansen. She comes from IBM, and she's going to talk to us about thriving in the cloud and going beyond the 12 factors. Hi Grace, how are you doing?
Hi, I'm good, thank you. Thanks so much for inviting me back again. It's great to join you all.
It's great to have you here as well. So go for it. We'll talk soon
Great.
for the questions.
Fantastic. Thanks so much. So yeah, as I've been introduced already, so thank you for that. But I'm Grace Jansen. I live in the UK. I'm a developer advocate at IBM, and I focus primarily most of my time on sort of, I guess, more Java-related technologies, the JVM, reactive technologies, and cloud technologies. So today I'm going to be running through sort of how we go beyond the original 12 factors to not just enable our applications to survive in the cloud, but to thrive in the cloud. So really making the most of that cloud infrastructure and designing our applications to be cloud native and to really thrive, like I said. If you've got any questions, please feel free to put them in the chat and I will do my best to get round to them at the end. So without further ado, I'll get started. So how did we get to this stage of designing these applications that are utilizing this cloud infrastructure? Why are we excited by the cloud? So we had this gradual evolution process where it sort of started with our underlying infrastructure evolving. So we used to have sort of more single core units. We're now able to take advantage of multiple cores, and with that, multiple threading. We're also able to take advantage of things like virtualization and containerization. And by enabling all of this infrastructure, we were then able to evolve our applications to benefit from that new, modern, improved infrastructure. So we then had this evolution in our architecture where we moved away from sort of more bulky, monolithic style applications, and we started breaking them down more, whether that's into microservices or perhaps more modular monoliths or macroservices or even down into functions. By breaking apart the sections of our applications, we were able to create easier deployments in terms of getting them up and into the cloud. We were able to sort of maximize the usage of the resources by enabling those resources to be associated with certain services, depending on the load to our system. We could easier find bugs. We could replace certain parts of our application without having to bring down and bring back up the entire application. So great benefits that we gained from being able to evolve our applications because of this underlying infrastructure. And this led to sort of this trend of, the cloud. So if you've ever seen Toy Story, you might get this reference. If you haven't, please go and watch Toy Story. The cloud is just my way of showing our excitement towards this trend of creating applications that really take advantage of this and offer clients and stakeholders and customers all of the sort of benefits that the cloud offers. And what are those benefits? Well, there's various different ones. There's a huge range of benefits and advantages that you can gain from creating a really truly cloud native application and taking advantage of that modern infrastructure. One of those is cost. So the fact that you're able to utilize this shared infrastructure that's managed by a cloud provider means that they're essentially providing that infrastructure at economies of scale. So because they're doing it at economies of scale, they're able to cost save and thus pass some of that cost saving on to you as the customer or the client. You're also able to be much more cost effective in terms of the resources that you're paying for. So you can scale your resources up and down depending on the load to your system. So you don't need to pay for the maximum amount of resources you have to sort of account for that maximum amount of load. You can shrink it back down when your load decreases, which makes it much more cost effective. There's also speed. So being able to rapidly provision new resources, for example, if your application load increases, and being able to spin up new versions of your application really rapidly in that cloud infrastructure. And that sort of ties into scalability, being able to scale up the number of resources elastically, so scaling them up and back down again at speed. And that leads to resiliency. So resiliency is another benefit because, if your one particular part of your application goes down, you can spin up another instance of it fairly quickly because the infrastructure is already there ready for you to use. If, for example, a data center were to go down, by using that shared infrastructure, you could move it to a different server or a different data center or even a different country, depending on your cloud provider. And this means that you have this increased resiliency just in case something like that were to happen. It allows flexibility because you can move it about. You can also move it across different cloud providers because there's this sort of shared infrastructure layer that's utilized. And it also enables our applications to take advantage of this fashion to move to cloud. You might not think of software development as a fashion industry, but actually it can be. We follow trends, we follow fashions, we follow innovation that occurs within our industry in order to offer that innovation to our clients and customers and provide that difference or that differentiating factor from our competitors. So enabling sort of building applications for cloud native and enabling them to use that underlying cloud infrastructure enables us to offer all of these benefits and to really gain from them. So what does it mean to actually build a cloud native application? Because that's essentially what we're trying to do here. We're trying to build applications that thrive in the cloud, that are designed for the cloud. So I took a look at a few different various definitions, and this was one of the best ones I came across, which was by the CNCF. So clues kind of in their name. They're pretty good at cloud native. So they sort of defined cloud native as technologies that empower organizations to build and run scalable applications in modern dynamic environments, including public, private, and hybrid clouds. So this is what we're aiming to do. We're aiming to enable our applications to be built, to be scalable, to be dynamic environments, utilizing this underlying infrastructure. So how do we go about actually building that? Well, the original methodology that was often jumped to was the 12 factors. If you've not come across the 12 factors before, this is a methodology that was defined a few years back now by developers at Heroku, and it was designed as sort of a map, I guess, or a list of characteristics and things you should think about for building cloud native applications. So trying to match that description we just saw. And it was based on 12 factors, as the name suggests. And it was designed to be able to be applied to any application. So it's technology, platform, and language agnostic. It doesn't specify or have opinions as to which ones you should utilize, which means that it's very highly applicable in terms of utilizing it in any application. So the original 12 factors are as follows. So you had code base, dependencies, configuration, backing services, build, release, run, processes, port binding, concurrency, disposability, depprod parity, logs, and admin processes. These factors, I would say, served as a really excellent introduction to sort of this discipline, I would say, of building and deploying applications in the cloud. But not only that, but also preparing teams for sort of the rigor needed to be able to build a production pipeline to enable these cloud native applications. So it wasn't just about sort of the code base itself and the logic within that application. It also introduced organizations and development teams to the sort of organizational and business process side of things in terms of enabling their organization to encourage and enable those characteristics and those that code logic to be cloud native. And as I said, this served as a really great introduction. However, we've evolved since this 12 factors was created. We've evolved in terms of our infrastructure, in terms of our application architecture, and in terms of the tools and technologies that are available for us to make the most of when we're building cloud native apps. And so sort of evolving this, just like our infrastructure evolved and our application architecture evolved, we've evolved this methodology to extend it and add on to those original 12 factors to take advantage of this innovation. So now we have this revised 15 factors. So we're going beyond those original 12 factors to now do 15. And this is it's still loosely based around those original 12 factors, but there are some revisions to some of those originals, and there are also 3 additional factors that are added here. Now, this was originally sort of documented in an ebook you can find online, and I put the link there. The ebook is called Beyond the 12 Factors, and it's by Kevin Hoffman. So this is his revised 15 factors that we're taking a look at today. So the 3 that were added in addition to the original 12 were API first, telemetry, and authentication and authorization. And we'll have a look at each of these factors, because as I said, some of the originals have been revised and sort of added to as well as these additional 3 factors that he's added. So we'll take a look at them in closer detail, and we'll have a look at sort of how we can enable these factors through sort of processes, through technologies and open source tools that they can utilize. So in terms of these three additionals, if you've not come across them before, API first is all about really enabling teams to essentially work against each other's public contracts without having to interfere with sort of internal development processes. This is particularly important in cloud native applications because it's really highly likely that any service you build is going to be deployed as part of an application, and it's going to have to interact with other services in this sort of larger ecosystem of services that make up your application. So this is why it's particularly well suited to cloud development, because it really allows sort of rapid prototyping and support of service of that sort of service ecosystem. Then telemetry. So telemetry, actually, we just had a session on telemetry. So if you were in this track before, you probably caught that. For those who weren't, telemetry is critical for cloud native applications. We're now having this huge amount of different services involved. They're distributed across potentially multiple different clouds, different data centers, and it becomes building cloud native applications sort of inherently comes with more complexity. And so it's important that we're able to use telemetry to be able to monitor and sort of, just monitor your application and monitoring its performance, monitoring its health and key metrics in this sort of really complicated and highly distributed environment. So that's why telemetry has been added here as well. And then we have authentication and authorization. So authentication and authorization, essentially, this is referring to security. So if you'll notice in the original 12 factors, security wasn't really mentioned anywhere. But actually, security is a really vital part of any application, not just cloud native, but any application. But I would say especially for those deployed in cloud environments. Deploying in a cloud environment means that your applications are essentially being transported across loads of different data centers across the globe and executed within multiple different containers and accessed by almost an unlimited number of customers. So it's really vital that your security isn't just an afterthought for cloud native applications. It's a really important factor to be considering when you're designing and building your application sort of right from the very start. So that's again why, we've come to realize that there are additional factors that are important when we're designing cloud native applications. So let's take a look at each one of these in greater detail and see just how we can enable them to be able to really thrive in this environment and not just survive. So the first factor that we took a look at was one code base, one application. So you'll see at the bottom here, if it's a red or sort of orangey color, that means that I've linked it to one of the original 12 factors. If you see a bluey color, that means it's one of the new factors that's been introduced in the 15 factors. So here, one code base, one application essentially links back to the original first factor in those 12 factors, which was just code base. So cloud native applications in this factor is all about cloud native applications consisting of a single code base that's tracked in a version control system, just like the first factor in the 12 factor app methodology. A code base is essentially a source code repository or a set of repositories that sort of share this common root, and they're used to provide any number of immutable releases. So not only that, but in this particular sort of revision of the original factor, we delve into the fact that it's also one application. So it's about the fact that we have this one-to-one relationship between the application and the code base, but we have a one-to-many relationship between the code base and the deploys. So it's all about having a single application that is stored in a single code base, but that can be deployed to various different environments. So that includes deploying to production, staging, QA, DevSecOps, developer, and any other development environment or any other environment you might need. And the reason for this is that it helps by having this single code base, we enable greater collaboration between development and various other teams. We also enable proper versioning, which is really important if you need to roll back for any reason, if there's bugs, for example, or if you're trying to audit your application. Being able to enable versioning correctly is really important, and having this single application and this single code base enables us to do that. And it also enables us to have faster time to market because everything's in one place. How do we achieve this? Well, we can utilize Git repositories. So you might already be using GitHub or perhaps GitHub Enterprise or even GitLab. And then there are other alternatives, like, for example, Bitbucket, SourceForge. You might be using a specific cloud provider's version. So there are examples like Google Cloud Source Repositories or even AWS Code Commit. So there's various different sort of Git repositories you can utilize or code bases you can utilize. These are just some of the most common ones that you often see. So we looked at the first one. It's fairly similar to the original 12 factors, but it's also focusing on that single application, that one-to-one relationship as well. Then you've got API first. So in regards to these factors, this is one of the new ones. And what you'll notice as we go through these various factors is that some are really specific about sort of specific physical requirements or technologies or sort of methodologies utilized when you're actually coding, whereas others are more around sort of encouraging specific habits or processes of the people and the organizations, as opposed to necessarily imposing a physical requirement or a requirement on the code. So this is an example of that. So API first, what do I mean by that? API first really means that what you're building is an API that's going to be consumed by client applications and services. So it's all about having this sort of API first approach. You're thinking about the API before you do anything else. This gives teams the ability to work against each other's public contracts without having to interfere with the internal development process. So essentially what you're doing here is you're enabling by getting together and doing this sort of design phase where you're looking at, okay, what APIs are we going to be producing? Because essentially that's what my service is going to be. My application is going to be consumed in some way as an API, whether that's as a website and your customer is consuming that as a website, that's still kind of an API because they're still consuming it in some way, or whether that's another backend service is going to be consuming from that API. It's about stopping before you write any of the code and thinking about what exactly are you providing to your customers or to the other services that are going to be utilizing your service or application, and how are you enabling them to get access to that information or access to those services through the APIs that you're going to be offering. And why we want to include this factor is essentially to help avoid integration failures and to really formally recognize our API as a first-class artifact of the development process. It's important. It helps to enable greater collaboration with stakeholders. So you're designing what they need for each API or service, and you're able to create greater documentation from that and mock up the API first, which means that you have this opportunity to test or to vet your direction or your plans before you invest too much into supporting a specific or a given API, enabling much greater flexibility if, for example, you needed to change that or add in an API or edit it in some way. So how do you achieve this? Well, you need to be sort of willing to be participants in this ecosystem. And to do that, you need to be able to provide these public contracts. And you can utilize tools or technologies like, for example, the Open API initiative, or other ones like API Blueprint. You can also utilize specific tools that then implement these specifications, like, for example, MicroProfile Open API. If you've not come across MicroProfile before, it's a fantastic open source sort of community specification that really enables Java EE and Jakarta EE, so enterprise Java developers, to make the most of this open source development and to be able to utilize it to create cloud native microservice-based applications. So it's a set of APIs, one of which includes this MicroProfile Open API that you can make use of. You could also utilize sort of proprietary products like Apiary or even IBM's API Connect tools. If you've not come across some of these specifications before, I definitely recommend checking them out. They can be really interesting to take a look at. So here you can see by really putting the API first, we can enable our applications to be cloud native because they're in this ecosystem of services that are all interacting. Before we put all this effort into code, we can make sure we're going down the right direction first. So that's why API first is a really important new factor we've introduced. The third factor is dependency management. Again, this links back to another factor in the 12 factors, the originals, and that's just dependencies. So in sort of classic enterprise environments, we're sort of used to this concept of sort of the mummy server, which you've probably come across before. This is essentially a server that provides everything that our application needs and takes care of their every desire, from sort of satisfying the application's dependencies to also providing a server in which to host the application. Whereas in the cloud provides this sort of maturation or maturity of the classic enterprise model. So because of that, we need to make sure that our applications also grow up to take advantage of the cloud. We can't assume anymore that a server or an application container will have everything that our application possibly needs, like the original Mummy server. Instead, we now need to bring our dependencies with us when we're deploying our applications. So migrating to the cloud basically means that we need to mature our development practices and sort of wean our organizations off this need for a Mummy server. So now we need to be explicitly declaring and isolating our application dependencies. And we can do this by sort of utilizing a declaration manifest, and that might be stored within the code base itself, or using dependency isolation tools during application execution. So why are we doing this? Well, as I said, we can't make the assumption that within our application container or within the cloud, we're going to have all of the dependencies that we possibly need, all the versions of those dependencies that we need. So by explicitly declaring and isolating them, we can provide consistency between the various different environments that we're deploying our application to, whether that's development, production, testing, QA, whatever. We can also simplify setup for developers who might be new to the application. And it enables us to support portability between different cloud platforms, giving us much greater flexibility in terms of where we can deploy our applications and ensuring that it's going to be sort of consistent across all of those cloud providers and across all of those platforms and environments. And this really enables greater developer productivity at the end of the day. We're not having to go into each individual sort of class, looking for each of those dependencies. If we need to change cloud provider or environment or whatever platform, we're able to have it all within one specific manifest and easily change that if we need to increase the version, for example, or edit it in some way. So how do we achieve this? Well, instead of packaging the third-party libraries inside your microservice itself, we need to specify those dependencies in an external file of some kind. So you might be utilizing something like Maven or perhaps Gradle, and it can be really useful to be utilizing things like the Maven pom.xml or the Gradle settings.gradle file, because this enables us to, as I said, freely move up the versions and separate it from our original code base. So it doesn't matter where we're deploying to. So dependency management here, we've just sort of taken it one step further from the dependencies and talked about sort of, it's not just about sort of defining and stating your dependencies themselves, it's also about managing them in a way that's effective for cloud native. The fourth one is design, build, release, and run. Now you'll notice this is almost identical to the original factor. In this time, we've sort of switched the order a little bit. So now it's number 4, it was previously number 5. But in the original one, they didn't have this design phase. So we've added this design phase in. And that's because essentially a single code base is taken through this build process. Essentially, this design stage is important, and it was missed the first time round. And since we've started moving to this cloud native type architecture, I think we've realized more and more how important it is to stop and think about the design before we actually rush in and start building our applications. And this design stage isn't about, we need to design the entire application end to end like we did in waterfall development. No, we want to stay agile, but it's still important that we design even the smaller features that get released. It's about having high level design that's used to inform everything we do, but we also have to bear in mind that that design might change. We might need just small amounts of design in every part of the iteration process rather than it being done entirely up front. So it's about sort of understanding that we need to have this higher level design to follow as we create our applications and build them, but we do need to understand that they might change as we go. And then the other sort of stages, so build, release, and run, are essentially, as you'd expect. Build stage is all about, having a code repository and where that's converted into this sort of version binary artifact. It's during this stage that dependencies are declared, and we're able to fetch them and bundle them into the build artifact. So in the Java world, you'd probably have a war or a jar file. Then the release stage, again, as the name suggests, this is essentially where you create your release. So the release is typically done when you push your application to your cloud environment. The output of this stage is essentially combining your environment and app-specific configuration with sort of the information that you need to produce this immutable artifact, which is a release. These releases are usually unique and they're identified with sort of a unique ID so that we can then, again, know which version we're utilizing. Then you've got the run stage. So run, again, it's sort of typically done in a cloud provider. The details vary among providers, but the general pattern is that your application is sort of placed within some kind of container. That might be Docker, Garden Warden, and then a process is essentially started to launch your application. So this factor here is essentially, we have added the addition in this 15 factor of design, but the whole point of this one is that we are strictly separating out the various different build sections or stages that we have. And this is important because it allows us to prevent sort of changes to the code or configuration at runtime, which enables us to lower the number of unexpected failures. It also enables more effective release management, and it enables maximum delivery speed while still keeping our confidence high that, through our automated testing, we've been able to make sure that there won't be any unexpected failures. This is sort of more of a methodology thing. So again, I talked about the fact that it might not necessarily link specifically back to a process. It can be just more about process within the organization and the people. But it can be sort of worth considering for this stage, utilizing a CI/CD pipeline, which can help you to be able to automate the process going through these various build stages. And a tool that might be useful to do that is Tekton. So if you've not come across Tekton before, I've got some links at the end of this slide that can help you run through sort of how you can utilize Tekton for that CI/CD pipeline. So the next factor is configuration, credentials, and code. So again, this links back to the original configuration factor, but in the original, it only stated that you should store configuration in the environment. But in this updated one, we're trying to be a bit more explicit. So when I say configuration, I'm referring to sort of any value that can vary across deployments. That might be URLs or other information about backing services. It might be information located to sort of how you locate and connect to databases. It might be credentials, that's also included, mentioned in the title here, or it might be information that normally is bundled into properties files or configuration files. Credentials, in this case, are extremely sensitive information, and they have absolutely no business being in a code base for obvious reasons. You do not want any Tom, Dick, or Harry being able to access those credentials freely just by looking at your application code, if they're able to get hold of that. It's obvious that we don't want that within our code base. So it's important that we're able to sort of utilize this factor of externalizing our configuration to be able to sort of make sure we're not leaking any credentials like that. This factor relates to sort of the golden rule of cloud native applications. And that's the fact that they should be able to be written once but configured everywhere. So they should be able to run anywhere. And that's why it's important that we utilize sort of environment variables to be able to externalize this configuration outside of our application logic. So this factor is all about ensuring really strict separation between code and configuration, and that configuration includes credentials. It's about storing that configuration in environment variables, which is sort of nowadays considered best practice for externalizing that configuration. It enables us to be able to modify our application behavior without making any changes to our code logic. It helps to simplify deployment to multiple environments. It enables us to reduce the risk of potentially leaking those credentials and passwords, and it enables even more effective release management. So it's all about, the how of this is just by extracting all of your application config and making them external or environment variables. And we can utilize things like microprofile config. So again, this is another of the microprofile APIs. So this microprofile config enables us to place that configuration in properties files that can then be easily updated without having to recompile your microservices. And on top of that, we could also make use of another microprofile API called CDI to be able to inject those properties back into our application. If you're interested, I put on a couple of these slides where it relates to it, some links to some of our Open Liberty guides. So if you're interested in getting hands-on with some of these specific technologies or specific factors or behaviors, then check out the links I put on each slide. And I've got some additional links at the end of the presentation. So the next one, logs. So again, this links back to an original. We've changed the order this time, though. It's now number 6 instead of number 11. So this is pretty similar to the original one. Essentially, what this factor is all about is treating logs as event streams. So only utilizing stdout and std to be able to log our logs. And essentially, the point of this factor is that unlike sort of traditional applications that might have run on premise, a truly cloud native application should never concern itself with the routing or the storage of its output stream. And this is because essentially we're trying to improve our flexibility for introspecting behavior over time and enable real-time metrics to be collected and analyzed without having to write that into our application logic. So we are making logging a platform concern and not a developer concern here. So how do we enable this? Well, we should only be using stdout and std to be able to log our logs. We need to be treating them as event streams, so essentially as events that are occurring over time and that we can look back on and retrospect and analyze. And we need to consider the aggregation process. So the fact that we're aggregating, processing, and storing logs, we need to think about sort of the fact that it will grow over time. So we also need to bear that in mind. We can utilize tools, though. There are many tools out there that are specifically designed for collecting logs and enabling you to display those to be able to analyze them and see what's going on in real time in your system. So we can utilize things like the ELK stack. So that's made up of Elasticsearch, Logstash, and Kibana. We could also utilize tools like FluentD, Splunk, or any number of other tools that essentially enables you to capture and then analyze your log emissions. But essentially, this factor is all about, it shouldn't be a developer concern. It's now a platform concern. So treat them as event streams and utilize tools available to be able to automate that process. Okay, so the next one is disposability. So this is factor number 7 in our new 15-factor app methodology. Originally, it was number 9. So disposability is all about enabling really robust, sort of maximizing the robustness of your application by enabling really fast startup and graceful shutdown. An application can't scale, though, or deploy, release, and recover rapidly if you can't sort of rapidly shut down gracefully as well. So we need to be able to build applications that embrace and take full advantage of the platform to be able to create fault-tolerant microservices that are able to be easily deployed, easily released, easily scaled, but also easily and gracefully shut down. So it sort of relates, I've got a very vague image here on my screen. So this sort of relates to pets versus cattle. So originally, our applications were more like pets traditionally. They were, unique. We gave them names. We cared for them. We had this emotional attachment because we'd worked for so many years to create them. And they were unique and lovingly cared for. When they got ill, we'd nurse them back to health, just like a pet, like Grace the cat here. However, we don't want to be creating pets because our microservices in this cloud native environment need to be easily disposed of, need to be easily replaced, easily scaled, easily deployed, but easily shut down as well. And that's why we want to move more towards this sort of cattle way of thinking. In cattle, they're not given names. This is a generalization here. They're not given names. They're given numbers instead. When they're ill, you just replace them with another generally. You don't nurse them back to health. And they're almost identical to the other cattle that you might have. So we want to go sort of brutally more around this cattle model because we need to be able to be resilient to unexpected occurrences and be able to increase our load by following this pattern of being able to shut down unhealthy microservices, bring up healthy ones, replace it with an identical version, just like in cattle. And this disposability really enables us to be very fast and very elastic in terms of our scaling. It allows us to have really rapid deployment of new code or configuration changes because we can bring down a microservice really quickly with the old config and bring up a new one really rapidly. And it enables robustness in production deployments. And it really enables this sort of concept of auto scaling without us having to manually deal with that. So how do we do this? Well, we need to minimize work on startup, so don't depend on any shutdown hooks. And we also need to maximize robustness with fast startup and enabling that through automatic scaling. We can utilize things like microprofile fault tolerance for this, which enables us to, again, make sure that our applications have fallback behavior, for example, if something were to go wrong. So what should be spun up again? What should happen? What are the actions that need to be taken? And if you're interested in checking out more about fault tolerance, check out the link that I provided there. So it's important that we're able to dispose of our applications and have this disposability factor in our cloud native apps, following more of the Cathal model. The next factor is backing services. So backing services here are any service on which your application relies for its functionality. So it's a really broad definition and it's a really wide scope intentionally. Some of the most common types of backing services includes data storage, messaging systems, caching systems, basically any number of other services that perform sort of line of business functionality or security. And in this factor, we're basically looking at the fact that there should never be a line of code in your application that tightly couples that application to a specific backing service, because we can't guarantee that that backing service is necessarily up and running, is healthy, is available. So we need to make sure that we're creating sort of bounded resources here. So what I mean by a bounded resource is essentially just a means of connecting your application to a backing service. So a resource binding for a database might include a username and a password and a URL that essentially allows that application to consume that resource. But we need to make sure that we're treating everything as a backing service that we need to, including things like databases, and treating them as this bounded or attached resource. There should also be no distinction between local and third-party services, and we need to attach resources via URLs stored in an application's config. Why are we doing this? Why does this factor get included? Well, it helps to really enable us to keep that concept of loose coupling, to make sure that we're not tightly coupling the various aspects of our applications, because that could potentially lead to sort of synchronicity, and you're essentially getting the worst of both worlds there, because you've got sort of the tight coupling of a more monolithic style application, but you've distributed loads of microservices and you're having to manage them all. So it's important that we don't have that coupling. So by enabling this sort of concept of treating everything as a loosely or bounded attached resource as a backing service, we can enable that loose coupling between service and deployment. It also means that we don't need any code changes if we need to update or change our backing services. And it allows our operators to sort of swap out services as and when they see fit. This really enables and sort of cements the idea of increased resiliency and agility, being able to attach and detach bound resources at will. So how we do this is essentially just a process thing. So it's about really taking the time to understand, okay, what does my application rely on? Can it be treated as a backing service? Should it be treated as a backing service? And we can utilize things like my profile config to help with this again. The next one is environmental parity. So while some organizations have managed to achieve this, many of us have often worked in an environment like the following. So we have shared development environments that have a different scaling and reliability profile to our QA environment, which is also different to our production environment. Usually the database drivers used in development and QA are different to production. We have different security files, firewalls, and other environmental configuration settings. And it basically means that on top of this, we also generally, a lot of the time, have some people have the ability to deploy to some environments, but not to others. And essentially what happens is people fear deploying because they have little to no confidence that if the product was to work in one environment, it would actually work in the other. So it becomes this huge mess of, the developers aren't confident, the code doesn't work, you're coming across unexpected failures as you move between the different environments. This factor here is all about negating those unexpected failures. It's trying to make every other environment that you have, whether that's development, QA, DevSecOps, production, for example, as similar as possible. And that's to be able to lower that risk of unexpected errors and support that continuous deployment model. It really enables us to have greater reliability in our code, knowing that if it works on one environment, it will work on the other because they're as similar as possible. Excuse me. So how do we enable this? So we need to ensure that we have the same backing services that are used for all deployments in all of them. We need to ensure we have this solid, continuous integration pipeline. We need to be able to deploy to production as often as possible to ensure that we have, confidence in what we're producing. And automated CI/CD pipelines can help with this, like we mentioned before with Tecton. We can also utilize container tools, for example, like Docker, because that can really help us to enable this more prod-like environment and more accessible to developer workstations. And building off that, we can utilize testing frameworks like microshed testing. Microshed testing is all about utilizing containers to be able to accurately test our applications in production-like environments, so mimicking that production environment for our testing. So again, check out the guide here if you'd like to take out more info about microshed testing. Then we've got administrative processes. So this is all about running admin or management tasks as sort of one-off processes. And sort of that might include things like one-off debug tasks. This is more about sort of enabling safe debugging or admin of production applications, and enables, again, greater reliability. We can utilize things like Kubernetes tasks to be able to take care of this for us. Or alternatively, you could use things like AWS Lambdas if you wanted to. Then we've got port binding. So port binding here, again, links to that original one in the 12 factors port binding again. So the principle of port binding essentially asserts that a service or an application is identifiable to the network by its port number, not by its domain name. So your cloud provider in this case should be managing the port assignment for you, because it's likely also managing things like routing, scaling, high availability and fault tolerance, all of which require the cloud provider to manage certain aspects of the network. So an application developed with exported port binding in mind really supports the environment-specific port binding without having to change any of your code. So this really enables greater ops efficiency and enables us to sort of assign these associated IP addresses, for example, and domain names on the fly, and having this automated service discovery mechanisms. How do we achieve this? Well, we can export services via port bindings. We can utilize things like microprofile config again. So microprofile config can basically enable us to utilize things like Kubernetes config map, where we can specify the new port, and microprofile config can then automatically pick up the new value to give the correct information to the deployed microservices. We can also utilize things like microprofile REST client, which can help us with sort of creating client code to connect from one microservice to another. So again, utilizing things like Kubernetes config maps and microprofile can be really helpful in this factor. The next one is stateless processes. So this links into processes. Again, in this updated factor, we've tried to be a bit more explicit, a bit more specific. So essentially, this is all about the fact that microservices should be stateless. This is all about executing the app as either one or more stateless processes. In actually the 15-factor book, it's argued that it should only be one process, but it could be more. It's basically ensuring that all of your stateful data is stored in a backing service. So all long-lasting state must be stored external to the application, and you do that by providing these backing services. So this enables us to sort of reduce our deployment complexity, reduce operational complexity, and allow for much simpler scaling. Excuse me. And it enables that cloud compatibility. How do we achieve this? Well, don't store any stateful data without storing it in a backing service. So make sure you've got those backing services available. Please don't use sticky sessions or the local file system. You shouldn't be using any in-memory caches. Storing in-memory caches that your application thinks are always available can really bloat your application and essentially make each of your instances take up far more RAM than is necessary. So try, if you need to cache anything, use third-party caching products like, for example, Geode or Redis, or there are many other examples. Try using those instead, like Jcache, as they're designed to act as backing services for the caching that you need in your application. So really utilize these tools. Again, you can utilize things like microprofile, Geode, and Redis. Then we've got concurrency. So concurrency, again, relates to the original. In the original, it sort of advised us that cloud native applications should scale out using the process model. So there was originally a time when if an application reached sort of the limit of its capacity, the solution was just to increase its size. Whereas if an application could only handle some number of requests per minute, then what was considered the perfect solution was to just simply make the whole application bigger. But adding CPUs, RAM, and other resources to a single monolithic application is essentially vertical scaling. And this behavior nowadays is typically frowned upon. What we want is the much more modern approach of sort of horizontally scaling. So being able to elastically scale the specific resources we need. So rather than making a single big process even larger, we create multiple processes and then distribute the load of your application among those processes. So this is linking back to the previous factor, which is, again, why they're in this order. So having this process-driven style, or this process-driven model, and utilizing that to enable us to be able to dynamically and elastically scale them up and down depending on our workload. So why do we do this? Well, it enables us to easily and horizontally scale them instead of vertically scaling them. And that enables us to be much more efficient with the resources that we're utilizing to deal with that increase in load to our application. And we can utilize things like auto scaling. So how do we achieve it? Well, we need to split out our app into separate runnable processes, just like in factor number 12, and then scale those independently. We can use tools like Kubernetes Autoscaler to be able to help with that. Then telemetry. So this is another new factor. So telemetry is sort of linking back to Ricardo's session, who's before mine, is all about sort of building applications on cloud native that we're able to monitor in real time. So we might be monitoring the performance or domain specific telemetry or even health and system logs. This is important because sort of modern applications are much more complex. We have added complexity when we introduce them into sort of this cloud native environment. So it's important that we're able to monitor them in real time to be able to check that they're healthy and they're working okay. So here are some guides that you can check out. We can utilize for this microprofile metrics and health to be able to help with this. And then the final factor is authentication and authorization. Again, a new factor. So this is all about enabling security, which is vitally important to our applications. And this is all about enabling that through RBAC, so role-based access control, authenticating and then making sure that each user is authorized to be able to access the specific parts of our application, increasing our application security. So we can utilize tools, for example, to enable this, like OAuth, for example, OpenID Connect. And again, linking back to microprofile, we can make use of things like JWT, JSON Web Tokens, to be able to authenticate, authorize, and verify users. Again, there's a guide there if you'd like to check it out. All of these together enable us to have these important characteristics that we want when we're trying to create applications that thrive in the cloud. So this is why they're all important. They link back to these important sort of characteristics or behaviors that we need for the cloud. If you want to get hands-on, I've shown you some of the guides throughout. We've also made them interactive. So if you don't want to do it locally on your own machine, you can go to our online environment and you can access those there with all of the different technologies that I've mentioned and the tools throughout this presentation. They're based on our guides that I've linked to throughout. In summary, essentially, hopefully I've shown you that the 12-factor applications are a great start, but in order to thrive in the cloud, we have to look beyond that. And there's no excuses. There's loads of open source tools and technologies to be able to help you on this journey. So my action, hopefully for you guys today, is to evaluate your own applications against these 15 factors and consider what you could do to enable them to truly thrive in the cloud. Could you take any that you maybe haven't implemented before and implement them in your own application? As I said, some useful resources going forward, if I haven't given you enough links already. So some useful resources here for sort of general and some linking to the specific factors that I mentioned. And I'll put these slides up online so you can access those. Thanks very much for listening. Hopefully I'll get to some questions. And if not, feel free to ping me on Twitter. My Twitter handle's there.
Thanks very much, Grace. I'm afraid we don't have any questions both on Slack and on YouTube. But, well, we are almost out of time, so we can move on. Will you put the links for the presentation on Slack?
Yes, yeah, I can put them on. Sure, yeah, absolutely.
Okay, thanks.
That makes it a bit easier for people. And I'll share the slides online as well, which will make it a bit easier.
Thanks for that. So Grace, thanks very much for being here another year. Hopefully at some point we will be able to be on a live conference here at Coimbra in Portugal. Okay, thanks very much and see you soon.
Thanks very much.